Somewhere between you and the center of our galaxy, right now, an invisible monster is moving through space. It has no light, it emits no radiation you could ever detect with your eyes. It weighs as much as 10 suns crushed into a point smaller than an atom. And it is traveling at hundreds of kilometers per second in a direction that, statistically speaking, could bring it closer to our solar system than any star has come in millions of years. You will never see it coming. Neither will we. And here is the terrifying part. There are not one or two of these invisible wanderers drifting through the Milky Way. According to the best estimates modern astrophysics can produce, there are approximately 100 million of them. 100 million rogue black holes. Wandering, silent, uncatalogued. Ours. This is not science fiction. This is not a fringe theory published by someone working outside the mainstream. This is the conclusion drawn from decades of stellar evolution research, galactic dynamics modeling, and some of the most rigorous computational simulations ever run on the history of our galaxy. The Milky Way is not the majestic, orderly spiral we sometimes imagine when we look at artists' renditions in textbooks. It is, in a very real sense, a shooting gallery shown, and most of the bullets are invisible. For most of human history, black holes existed only as mathematical curiosities. Einstein's equations permitted them. Theorists argued about them, and for a long time, the scientific establishment was deeply skeptical that objects so extreme could actually exist in nature. Then, one by one, the evidence began to pile up. We found stellar mass black holes lurking in binary systems, betrayed only by the X-rays they stripped from companion stars. We found supermassive black holes at the centers of galaxies, including our own, their presence revealed by the frantic orbital speeds of stars trapped in their gravitational grip. In 2019, humanity captured the first direct image of a black hole's shadow, a dark circle ringed by fire, sitting at the heart of a galaxy 55 million light-years away. In 2022, we did it again, this time photographing Sagittarius A star, the 4 million solar mass giant sleeping at the center of our own galaxy. But here is what those landmark images obscured. Here is what rarely makes the headlines. The black holes we have found, the ones we can point to, name, and study, represent a vanishingly small fraction of the black holes that actually exist. The ones we know about are the ones that gave themselves away. They had companion stars to devour. They sat at the centers of galaxies where everything around them moved so fast we couldn't ignore the invisible hand pulling the strings. They were the loud ones, the messy eaters, the ones caught in the act. The other 100 million? They are doing none of those things. They are simply traveling through the dark, alone, consuming nothing, revealing nothing, asking nothing of the universe around them. They are the quiet ones. And in many ways, that makes them infinitely more unsettling. To understand how something so massive can be so invisible, you have to understand what a black hole actually is, and more importantly, what it is not. A black hole is not a cosmic vacuum cleaner, endlessly sucking in everything around it. That is a myth, and a persistent one. A black hole is simply an object so dense that its escape velocity exceeds the speed of light. Get close enough, and nothing escapes. But at a distance, at a safe distance, a black hole of 10 solar masses pulls on you with exactly the same gravitational force as any other object of 10 solar masses. If our sun was somehow replaced by a black hole of equal mass, which, for the record, our sun will never become, Earth would continue orbiting exactly as it does today. Cold, dark, but gravitationally unchanged. This is precisely what makes rogue black holes so difficult to detect. Out in the open interstellar void, far from any gas cloud, dense enough to form an accretion disk, far from any star close enough to be disrupted, a stellar mass black hole is simply, say, there. No glow, no pulse, no signature, just a warping of space-time so localized that unless something passes extremely close, the universe offers us almost no clue of its presence. So how do we know they exist at all? The answer begins with the life cycles of stars. Stars do not live forever. Stars that are born large, 8 times the mass of our Sun or greater, end their lives in one of the most violent events the universe produces, a core collapse supernova. For a few days, a single dying star can outshine an entire galaxy containing hundreds of billions of suns. What remains after that explosion, if the original star was massive enough, is a black hole. The core collapses beyond the point where any known force in nature can halt it. A black hole is born. Now consider the age of the Milky Way. Our galaxy is approximately 13 billion years old. For 13 billion years, stars have been forming, living, and dying within it. Astrophysicists have modeled the stellar populations that must have existed throughout that history. How many high-mass stars formed, how many went supernova, and how many of those supernovae produced black holes rather than neutron stars. When you run those numbers, when you integrate star formation rates across 13 billion years of galactic history, you arrive at the same uncomfortable answer every time. Somewhere between 100 million and 1 billion stellar mass black holes should currently reside within the Milky Way. The most commonly cited figure sits around 100 million. We have directly confirmed a few dozen. The gap between a few dozen and 100 million is not a rounding error. It is not a gap we can hand-wave away with uncertainty estimates. It is a chasm that tells us something profound about the nature of our galaxy and the limits of our ability to see it. Almost everything we have mapped, almost everything we have named and catalogued and congratulated ourselves for understanding is just the visible surface of a far deeper, far darker reality. And yet, in recent years, something remarkable has begun to happen. Astronomers have started finding them. Not directly, not yet, but through whispers in the fabric of light itself, through a phenomenon so elegant it could only have been predicted by the mind that also gave us relativity. The tools we are now building, the observations we are now making, are beginning to pull these shadows out of the dark, one by one. The question of how we find something specifically designed by nature to never be found, that is where this story gets truly extraordinary. So we return to the question that haunts every astronomer who has spent time with this subject. If 100 million black holes are wandering our galaxy right now, silent and invisible, moving at hundreds of kilometers per second, what happens when one gets close? Not close in the way we think of close on Earth, not close like a neighbor or even a distant city, close in cosmic terms, close enough to matter. The answer depends on distance, and distance in space is a concept that humbles even the most experienced minds. Our nearest stellar neighbor, Proxima Centauri, sits about 4 light-years away. At the density of rogue black holes that current models suggest, the nearest wandering black hole to our solar system is estimated to be somewhere between 80 and 100 light-years distant. That sounds like a comfortable buffer. And for now, it is. But these objects are not stationary. They are moving. they are always moving. And over millions of years, the geometry of the galaxy shifts in ways that no living thing has ever witnessed. What scientists have calculated is that close stellar encounters, objects passing within 1 or 2 light-years of our solar system, happen roughly once every 100,000 years. Rogue black holes, being more massive than typical stars, would have an outsized gravitational influence during such an encounter. They wouldn't need to come particularly close to disturb the outer reaches of our solar system. The Oort cloud, that vast spherical shell of icy bodies that wraps around the solar system at an enormous distance, is gravitationally fragile. A massive interloper passing within a few light years could send cascades of comets raining inward, flooding the inner solar system with projectiles over thousands of years. This has likely happened before. It may be part of the reason mass extinctions have punctuated the history of life on Earth. A rogue black hole, invisible and unannounced, nudging the cosmic billiard table from the dark. But there is another side to this story, one that pulls us away from existential dread and towards something almost philosophical. Because rogue black holes are not merely destroyers, they are, in a profound sense, survivors. They are the remnants of the very first generation of massive stars to ever exist in the universe, stars that blazed into existence just a few 100 million years after the Big Bang, burned furiously for a few million years, and then collapsed. The black holes they left behind have been wandering ever since, while galaxies formed and merged and evolved around them. While stars were born and died across billions of years, these objects simply continued, moving, persisting, carrying within their structure the compressed memory of matter that existed before our solar system, before our sun, before the Earth, before any of this. When you consider that framing, a rogue black hole, is not a predator lurking in the dark, it is a relic, an artifact of a universe that no longer exists in that form. It has traveled further than any distance we can meaningfully imagine, through epochs of cosmic time that dwarf everything human civilization has ever produced or contemplated. It was already ancient when the cloud of gas that would eventually become our sun hadn't yet begun to collapse. The light from the star that created it faded before our world existed. And yet here it is, still moving, still bending space around it, still as real and present as anything in the night sky. This is what makes the study of rogue black holes so disorienting in the best possible way. They force us to reckon with the true scale of time, not just the scale of space. Astronomy often asks us to stretch our sense of distance, to internalize what a light year means, what a megaparsec means. But black holes, especially ancient wandering ones, demand that we stretch our sense of duration in a way that is genuinely difficult for human minds to process. Scientists are now building instruments specifically designed to detect these objects as they drift across the lines of sight between us and distant stars. The Nancy Grace Roman Space Telescope, set to observe billions of stars in the galactic bulge, is expected to detect hundreds of micro-lensing events over its mission lifetime. Some of those events will be caused by black holes. Each one will be a small window opening briefly onto an invisible world, a flash of bent light that says, "I am here. I have always been here. You simply couldn't see me until now." The implications extend beyond our galaxy. If the Milky Way contains 100 million rogue black holes, then so does every other large galaxy in the observable universe. The cosmos is saturated with these objects, moving through galactic disks, being flung out into intergalactic space during galaxy mergers, drifting through the enormous voids between clusters of galaxies. Some rogue black holes may have escaped any galaxy entirely and now travel through the intergalactic medium, surrounded by nothing but the faint glow of the cosmic microwave background, profoundly isolated in a way that has no analog in human experience. They will continue this journey for trillions of years, long after the last stars have burned out, long after galaxies have faded to cold, dark collections of stellar corpses. These objects will still be there, still moving, still bending space, outlasting nearly everything else the universe has ever made. That is the final thing to sit with. We live in the bright era of the universe, the age of stars, the age of light. It is easy, from inside that light, to think of the darkness as emptiness. But the darkness is full. It is crowded with mass and motion and history. It contains objects older than our sun, harder to see than anything we have ever tried to observe, and more numerous than most of us ever stopped to imagine. The rogue black holes wandering our galaxy right now are not aberrations. They are not accidents. They are the galaxy's dark inheritance, the inevitable product of stellar life and death on a cosmic scale. And they will be here long after the last human eye has looked up at the stars and wondered what else might be out there. The universe does not announce its most extraordinary contents. It simply holds them quietly in the dark, waiting for something curious enough to look. Join us soon for another documentary.